Hello, this is Scott Eustace, Community Science Director for Healthy Golf. I was going to go over our Louisiana petrochemical emissions contribution to state wetland loss worksheet as a proposal for commenting on LDEQ air permits for large facilities. Louisiana is a state that is drowning. We can see it happen. We photographed it. We look at Grand Chenier. We know there's nothing happening. There's no pipelines, no old oil fields, no diversions, there's there's no erosion because the erosion is distal and Bay Baptiste. Erosion hasn't gotten there yet. There's no shipping channels. And even the pipelines are farther away. So what is it? And what is the pattern? We see a waterlogging pattern. So since 1990, we've known it's regional drowning, and Dr. Shea Penland classified it as a natural waterlogging. We think it's less than natural. And we think the areas identified by Dr. Penland in the year 2000 from the 1990 photograph, they look a lot like the near-term red maps from CPRA when CPRA projects wetland loss into 2037. This is not unusual. Most states have a functioning, what they call a SLAM model, sea level rise against marsh model. And in Louisiana, we have the master plan modeling team, which explicitly can go one further and look at sediment inputs and outputs, look at project storms. I guess not just one further, a few further. I think it was Glick from National Wildlife Federation that did the last SLAM model for Louisiana, but the principles hold. But even if you don't believe sea level rise is happening, we can look at the past rates from 1932 to 1990 and see that was 20,000 acres. The petrochemical emissions from Louisiana facilities by themselves are enough such that if that is the continuing rate of loss from sea level rise, it still has to be documented. It's large enough to be documented and permitted, avoided, minimized, and mitigated. But we all know that is not the case. It's much larger. While we don't have specific quotes on this, in fact, Kareem Belhajali in 2016 mentioned this, the governor's advisory panel, and this slide was cause of much concern and moaning and disbelief, anger, grief. The committee was going through grief. Kareem left the CPRA not much later. But in Louisiana, we always have this myth that it's subsidence that's the problem and not sea level rise. Even as we say, oh, subsidence is lessening because we're not extracting as much oil as we did in the 70s. So there's a lot of double talk and double think about this issue. Kareem showed this slide. Basically, the blue bars are more significant than the green in most areas of Louisiana. And artificially, there's some lying here by overemphasizing the bird foot where the green is larger. The bird foot is the smallest of the areas in the entire state. So when you look at that map, this is really the bird foot. And, Kareem didn't report on areas around the Mississippi River. So, I mean, if you just take this face value and average them all together, if they were same, the rate is something like, 2/3 to 3/4 of the problem is greenhouse gas forcing and sea level rise, not subsidence. But when I've just rounded it up to 80 because there's areas that were even omitted from Kareem's slide. Recently, we've had the climate task force, which looked at Louisiana's contribution to the United States, which is significant at 4.1% average over time. Sorry, this is the long one. There we go. I just took David Dismuke's overall period, which is conservative, right? That's the lower. Because we're trying to, again, just be conservative. And even though we undershoot the problem, we still get significant numbers at the end of our process. And, we're trying to ward off some of the criticisms that way. So Louisiana is very significant, especially per capita in terms of emissions. We're both in the top four for emissions in the United States and in the top 4 per capita. So, West Virginia is pretty big per capita, but then not a big player in the raw data. Louisiana is the only player that is a significant contributor to both lists. We're both in the top 4 raw and then the top 4 per capita. I think Texas and Florida are 2 others, and then I forget what number 4 is in the raw data. Maybe it's California. So, and then we looked at the EDGAR data for how the US is shaping out globally. And we tried to keep it consistent with David Dismuke's method of looking at 1990 to 2018. Luckily, that's published, and so it's readily available. You can look at the average. The average contribution from the US is going down. But then again, we're doing these kind of broad brush pictures. So in 2018 itself, the US was 14% of the nation, of the entire globe. And while China was increasing and the EU was decreasing, but we're just leveling that back to 1990 as David Dismukes did. So that our 4.1 number and this number for the USA 0.18 is the same. So on this sheet, I have them marked as, the same time period. Generally, when we look at the petrochemical manufacturing contribution, we've got 66% from petrochem and another 13 from power generation, which is mostly petrochem, particularly because we want to be able to criticize Entergy and the coal-fired power. We put that in this number. Moreover, a lot of the petrochemical customers are a large consumer of Louisiana power, although we don't know. And a lot of the petrochem is going to making its own power, especially the ones that have learned lessons from hurricanes. So we just put both of those power emissions and petrochem. But if you can adapt this by going with the lower number of 0.66. And here I have a standard worksheet just saying that if the proposed facility exceeds 1.38, etc., megatons carbon dioxide equivalent per year, then it should be evaluated. I think maybe it might be easier to say if it's on the EPA flight tracker at all, it should be evaluated. But I think I picked that number just because it made Some of these other numbers are now prettier. Oh no. Oh, I have a little bit of a mistake in this form. Okay. I think, 1% is about 0.98 acres. So I think I was going with that. Although you can take this worksheet and make your own thresholds, play with it. We were suggesting this as a method to the state who doesn't want to do anything. So any improvement is good. So given that number, we can see that facilities that are part of Louisiana are a significant part of the global climate emissions. And from there, you could take this kind of analysis and say every one of these things is federally significant, if not globally significant. But we want to make it pertinent to Louisiana and wetlands that have been lost from standing climate change in Louisiana, as well as the future. So going into the future, that's where Kareem's slide was relevant to. He was presenting on the 2017 master plan modeling. So that's why I have them in the fourth column. I have a third column which just pertains to, wetlands that were lost from Louisiana, and only a part of Louisiana. This number doesn't include anything that was drowned in Cameron Parish, for example, or around White Lake or anything like that. This is Atchafalaya Bay east to the Mississippi border. So, but then what we have in lieu, we have a lot of dancing around this issue at CPRA, so I don't have direct references. Probably could go to Tor at Tulane with this, or maybe there's some geologists out there that want to help me refine this column. But what we have is Bren Haas responding to Tor's last paper in 2020 about this issue, saying that yes, we know, and CPRA's job is to ward off climate science by saying we've got this model and the model saves us. So, they let some information drop, and Bren did. He helpfully said that 75% of the 4,120 square miles of coastal wetland loss into the future, again, we're going, he's talking in 2020, so I'm assuming he's using the 2017 master plan model. That's going to be attributed to sea level rise. So we've so there we have, the discussion is always in square miles. That's how much we're going to lose from the rising sea, from greenhouse gas forcing, modulated a little bit because we do have a little bit of subsidence. I think if I were to, the more I refine this fraction, the more it goes up. This fraction, you could put it as low as 0.66, but no lower than that. And then these are lowering over time. We just wanted to be consistent with the Climate Task Force report, which is going to be a benchmark going forward. And we don't know if it'll ever be redone, right? So that time frame of 1990 to 2018, I think is going to continue to be relevant for this analysis. But obviously, if it drops to 13, you can really simply put that into the worksheet and get a number that's just a pretty linear extrapolation of percent times a very, very large number, which is 4,120 square miles of the United States. So that gives you quite a few acres, even if the facility is on the lower end of major petrochemical facilities. So even the methanol facilities that we're tracking, for example, should have this wetland evaluated, avoided, minimized, and mitigated. So this should be revenue generating for CPRA. At the very least, if they're going to be the custodians and say, this is our plan, we know the plan is not funded. So, right. So what does it look like when we look at, and I made this one, you know, it doesn't have anything. So I think a methanol facility is at about 2.3. You can calculate these numbers quickly. You can get percent increase, you know, how much of the 2018 CO2 emissions does this facility represent? Is it 5%, 20%? You know, no matter what number you put in here, it'll give you percent and then a number of acres. So saying that those are acres that have to be avoided, minimized, mitigated. The geography of those acres are defined by the CPRA red map. So I'm working on an environmental justice analysis of this, except we have language in the climate task force that we know that it's Native Americans and African Americans and low-income people that are most affected, fishing communities. You know, just read about Cameron Parish, read about Plaquemines Parish, read about Jefferson and Lafourche and the Houma Nation and the other tribes. It is an environmental justice issue. I think we can refine that through a GIS, but I think the point is to, you know, if you really want to, it's kind of impossible for any one facility to be mapped onto any particular acreage, except that it's a significant percent of the total. So I thought I'd work on this first. So generally what I do is I make a copy of this worksheet that has all the references linked and all of the, you know, formulas typed out like a spreadsheet. So we will look at something like the Formosa petrochemical plant. Well, if we have its AI number, we can find the document that says what its you know, contribution from CO2e is. It's usually in the PSD part of the Title V. Usually the CO2e is significant enough to warrant being part of the PSD. Something like this. And it's even easily, you can see it even if you're going through a 300-page air permit. It's usually page 7 to page 18, 7 to 17. You can find this table, which is it's either section 10 or section 12. But we have it linked there in the spreadsheet. We took that number, megatons, but it's just tons. It's over 13 million tons compared to this tonnage. Gives us a percent, so we can multiply the percents together and then get a range. So we have, but I didn't have the formulas quite right. Okay. We've got the estimates if sea level rise rates stay the same. And really it's if they stay the same and are confined to the eastern part of the state. So that 8.77 number should be higher. It's just we don't have a publication to work from. So, but then again, that's a minimum. Square miles lost from the Formosa facility if sea level rise is on the higher end and more like what Bren was talking about in that quote, 1.29 square miles of land lost. This is much larger than the footprint of Formosa. And what is that in acres? Because all the regulatory bodies think in acres. That's 823.03 acres. So that's highly significant. That's at least 3 highway projects. It's it's massive. So here we have a facility that's already getting an EIS. So we want to argue this in front of them. And again, the numbers stay high even if we change and lower some of our percentages toward the more favorable end. I can get it as low as 5 acres. Okay, that really changed it. Yeah, it's wrong. But to DNR 3 acres to 5 acres is it's considered a large impact. So, take it out of here. It's still big. Oops, missing a decimal place. It's still large at the smaller end. Right. Also, we can do the same kind of research for cumulative impacts analysis of LNG. Oh no, I don't have access. We've been tracking these different numbers. These are just the different permits and AI numbers for the different spreadsheets. I'm gonna make this open. To get this information, and then I summarized 10 facilities as 67 or so megatons carbon dioxide equivalent, and then put that in this LNG sheet. So given these 10 that are moving toward air permit, I think there's an 11th one. I just have to go back. Some of these projects are stalled. That's half of the current or the half of the 2018 flight emissions, and then it would be a third of the new total. So, and the project managers have repeatedly told us that these facilities are going to last 50 years. So that's really pushing us toward the higher number. The assumptions hold that these relative carbon emissions are going to be they're going to be stable. Our assumptions won't be violated throughout the next 50 years. So I think if you buy it about LNG, if LNG is supposed to save the world from coal, this number even goes up, right? So what we see from 10 facilities is over 3,000 acres of impact from land loss. So, I would like to present this to FERC. It is an environmental justice issue. I would like to present this to EPA because EPA has the ability to intervene. I think the regulators should like this because it's again, I'm doing the wrong thing. 32 acres at a minimum. It's within its numbers that are large, but are also within the regulatory world. They sort of know how to handle these numbers. So I think it is the perfectly reasonable thing to ask that these facilities be contributing to CPRA for wetlands mitigation at the very least. But it's going to require very unreasonable people to push this forward, to say that climate change is real and it's drowning Louisiana. We keep saying it in abstract, but then there's no regulatory backbone to actually use the law, use the science we have to get our land that we need to survive. So thank you. And I'll be sharing this out with a couple of people. If you email me at scott@healthygolf.org with any questions.